Good evening, Algebra students. So this is the final review for my 5th period Algebra class. So if you're not in my 5th period Algebra class, this really isn't going to help you all that much. Okay, so what I'm going to do is I'm going to go through, I'm going to do a couple from each type. So I'm not going to spend a tremendous amount of time going through it. The reason is that because if you guys are having trouble on this, you should feel free to sit there and pause it, rewind it, watch it again. If you're still having trouble on it, come in at lunch, stuff like that. We are at the very end. That doesn't mean there's not time. So just do your best. So, as we go. So these first ones are pretty straightforward. All you're really doing is looking at turning the words into an actual expression. So there where it says product, that means multiply. So we're multiplying 2 and n. So that's okay, or you can write that, either one. 3, sum, that's addition. So we'd go 11 plus 12. Now, we don't actually have to solve them, so you're not going to put down 23. That would be evaluating the expression. We just want to write it out. So if we looked at 4u cubed, we know that cubed means to the third power. So it'd just be u cubed. Moving on. So name this set or set to which each number belongs. So again, there's going to be maybe one or two of these on the final, so don't fret. We have real numbers, then we have rational and irrational numbers. Now the difference between rational and irrational numbers is that rational numbers can be expressed as a terminating or repeating decimal. Okay. Now, here's the nifty thing about square roots or roots in general. All roots are either perfect roots or irrational numbers, which means that if it's not the perfect square of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth, then it's going to be an irrational number. So let's look at 25. Square root of 25 is 5. 36. Square root of 36 is 6. Now 26, 7, 8, 9, 30, 1, 2, 3, 4, 5 are all going, if I took the root of any of those, so square root of 32, let's say, that's going to be an irrational number. So we look here, and we know that 83 is between 81 and 100. 81 is 9 squared. 100 is 10 squared. So that means that any number in between 81 and 100 is going to be an irrational number. So that would be it. Now, on the next one, we have 7 over 4. Now, because this is expressed as a proportion, or rather a ratio of two real numbers, of two integers, 7 over 4. That always means it's going to be a rational number. Now, it is not an integer. That's all whole numbers and they're negatives. It's not a whole number. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. And it's not a natural number, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So the only difference, keep in mind, between a whole number and a natural number is 0. Okay? So any other, except for 0, all whole numbers are also natural numbers. 0 is a whole number, but not a natural number. Okay, so now we get into evaluating. Now, what's the difference between evaluating and solving? Well, if we're evaluating, okay, so it's just a rational number there. So if we're evaluating, we get -6. Now, if we were solving it, it would be x equals -6. In order to solve something, you need not a variable, but an equal sign. If you just have a problem like this, what's -2 minus 4? Then you have an evaluation, not solving. Negative 5 times 5 is negative 25, because when you multiply a negative and a positive number, you get a negative number. So, next we're going to amp up the difficulty a little bit. Now here we're going to distribute. So we're going to distribute that negative 9 times 1, and then we're going to go negative 9 times 10. So we're going to do the same thing with the 7, so we end up with 7 times p plus 7 times 1. Now we're going to go ahead and actually do that multiplication. Negative 9 plus 90p, we have those two negatives, so it's a positive, plus 7p plus 7. Combine like terms, 97p minus 2. Okay, now notice on number 17, it says solve each equation. We've got that equal sign and we've got a variable. So when we're done, we should have x equals something. Here we got to get the x alone, so we want to perform the inverse operations. So we're going to divide both sides by a negative 4 because it's multiplied by a negative 4. And so we get x equals negative 18. Done and done. Moving down to 19. Same general idea. It's just a little bit more complex. Now we got 2 steps. Got to get rid of the 8, negative 8, and then the 8 by multiplication. We get rid of that negative 8 by adding 8 to both sides. Negative 8 plus 8 is 0, so we get negative 32 equals 8k. Divide both sides by 8, and we get k equals negative 4. Moving on. So here, we're going to have multiple steps, okay? So we have 1 step, 2 step, and then multi-step. Okay, we don't call it 3 step, 4 step, 5 step. If it's more than 2, we just call it a multi-step. So here we want to start off by distributing that negative 7. So we get negative b minus 56b minus 14 equals negative 356. We're then going to combine the negative b and the negative 56b and get negative 57b minus 14 equals negative 356. I'm going to add 14 to both sides. And we're going to get negative 57b equals negative 342. Divide both sides by 57, negative 57, and we're going to get b equals a positive 6. Why positive? Because it is a negative divided by a negative. Now, if I wanted to go and check my work, what I would do is plug that negative 6 in, or that 6 in for b, and see if I got anything. Now notice I stopped at negative 6 minus 350 equals negative 356, because by that time I should be able to figure out that I'm doing it right. So, moving on. Let's look at 23. So this time we have variables on both sides of the equation. So what we need to do is distribute through on both sides, and then we're going to combine like terms. So we have negative 36 minus 18x equals negative 18x minus 36. Okay, now if we add 18x to both sides, notice they cancel out. So we end up with negative 36 equals negative 36. So what we want to ask ourselves is, when is that true? When does negative 36 equal negative 36? Well, always. If I had solved for x, if I had like added 36 to both sides and then divided by a negative 18, I'd end up with x equals x. When does x equal x? All the time. So we say that this has an infinite number of solutions. Okay, now, absolute value. Now, absolute value is a little tricky, because once you get down to it, we have the absolute value of 1 plus x equals 1. Now, absolute values are normally going to have 2 different answers, and here's why. Absolute value relates not to, positive or negative. Absolute value is always positive because the absolute value of a number is how far away from 0 that number is. So if we know that 1 plus x equals 1, we're saying, when is 1 plus x? When is the answer to that 1 away from 0? Well, that's going to happen twice. It's going to happen when that equals 1, and that's going to happen when that equals negative 1. So we solve for both of those. We're going to subtract 1, and we get x equals 0, or x equals negative 2. Now, it doesn't matter which one I plug in there. On both of those, I'm going to get the right answer. Because both of those give me an absolute value where 1 plus x is 1 away from 0. Same general idea on 26. We're going to add 9. That's going to give us r minus 8, absolute value of, equals 12. We're then going to write out both possible equations. R minus 8 equals 12, and r minus 8 equals negative 12. We're going to add 8 to both sides on both equations. And so we're going to get r equals 20, 12 plus 8, or r equals negative 4, negative 12 plus 8. Now, both of those are going to be the correct answers. So if you have this, you need to make sure that you're answering both of those. 29, just solving for x. Oh wait, we're doing 27 first. So this time we divide by negative 5, so we get 10 plus v, absolute value, equals 2. So again, we set up 10 plus v equals 2, and 10 plus v equals negative 2. We then solve for v on both of those. Subtract 10 from both sides, and we get v equals negative 8 or v equals negative 12. Now for 29, solving for x, you just want to make sure that your equation ends up as x equals something. And that's called a literal equation because you're dealing with just variables there. So, inequalities. So inequalities are going to have two main parts. You want to make sure you have the circle at the right place. You want to make sure the circle is either open or closed. You want to make sure the arrow is pointing in the right direction. So here we have b is less than negative 5. So I put the circle at the negative 5. And I left it open. Why open? Because it's less than, not less than, or equal to. If this was be less than or equal to 5, negative 5, I would have closed the circle because that means that negative 5 makes this true. By leaving it open, I say this isn't true at negative 5, but at all numbers less than that. How do I know to draw the arrow to the left? Because its b is less than negative 5. Okay, if the arrow is pointing at the variable, it goes to the left. If it's pointing away from the variable, it's going to go to the right. That's simple. So next, we're going to deal with some simple inequalities. Again, one-step, two-step, multi-step. Now for the vast majority of these, we're going to treat that inequality sign just like an equal sign. Which means when we sit there and have x minus 5 is less than negative 18, we can just add 5 to both sides. So we add 5 to both sides, and we end up with x is less than negative 13. And then we graph it. Open circle at 13, arrow to the left. Same thing for 35. We're going to add 9 to both sides. We have x over 5 is less than or equal to negative 3. Multiply both sides by 5. X is less than or equal to negative 15. Now notice here we have a less than or equal to, so we're going to go ahead and we're going to fill that in. And then again to the left. Okay, so if that was x is greater than or equal to negative 15, and go to the right. So, compound inequalities. So these, we're either going to have them pointing away from each other or towards each other. So if it says or, we're going to have them pointing away from each other. If it says and, we're going to have them pointing at each other. So, we basically just want to use this as, wrong buttons, as two separate equations. I want to go and treat it like we have k plus 4 is less than or equal to 6, and, apparently I'm doing 38. So, here's where things get a little interesting. Now notice my first step here. My first step is I'm going to divide by a negative 3. Now this is the one time when we can't treat that inequality sign just like an equal sign. If we ever divide by a negative or multiply by a negative, we flip the sign. So now instead of 8r plus 1 is less than negative 41, we have 8r plus 1 is greater than 41. Now, keep in mind, when we're multiplying or dividing by a negative, that doesn't mean that a negative is involved in it. But the actual process, which we're doing to both sides, if we're multiplying both sides by a -5, or dividing both sides by a -4, or any negative, that's when we flip the sign. If I'd been dividing just by a regular 3 here, the fact that I was dividing -123 by 3, that wouldn't make me flip the sign. It's the fact that I'm dividing by a negative. Not that there's a division problem with a negative in it. So, here I'm going to subtract 1 from both sides. You get 8r is greater than 40. I'm going to divide both sides by 8, and I get r greater than 5. See, it's a 5, it's a greater than, so we go there. So now what I was talking about, 41, we're just going to treat this like 2 separate equations. We get k is less than or equal to 10, graph that, divide by a -6. Now again, we divide by a -6, so that means we're going to flip the sign. So instead of k is less than 0, we get k is greater than 0. Now notice here, go back, notice here we have 1 which is less than or equal to, solid dot, 1 which is greater than, open dot. Show you how both of them are done. Okay, moving on. Proportions. Proportions are fun and easy. Just cross multiply. So we get 8, 4 times 2 equals 9n. Divide both sides by 9. And we get n equals 8/9. If you're feeling special, want to write it out as a decimal, just put 0.8 bar. Same thing, moving on to 49. We're going to go 10 times 7 and b times 3. So we end up with 3b equals 70. Divide both sides by 3. And we get b equals 70 over 3. Or if we want to put it as a decimal, it would be 23.3 bar. Something like that. Yeah, exactly that. Okay, now, when we're dealing with percents, remember, it's is over of equals percent over 100. Now, a couple of you guys like to do it differently. Totally okay. So, if we look at 51, so we have what? 9% of what is 118. Now, notice in the is over of equals percent over 100, the 100 is always there, okay? So, now we just have to fill in the is, of, and percent. So first we have that 9. Why? Because it says 9%. Then we have of what and is 118. So the of what is going to go there, and the is 118 is going to go up top. So we end up with 9x equals 11,800. Divide both sides by 9, and we get x equals 1,311.1 bar. I know it's ugly, but that's how you do it. Okay? So here on number 53, the x is the what. What is? The of 24, 12%. Cross multiply, we get 100x equals 288. Divide both sides by 100, and we get x equals 2.88. So if we read that, we'd say 2.88 is 12% of 24, which is true. Moving on. Okay, so slope. Different ways to find slope. We can go rise over run. We can talk about it as the change in y over the change in x. Or we can talk about it as y2 minus y1 over x2 minus x1. Okay, now here on these graphs, it's easy just to count rise. So here we have a 4. It's going to be -4. Run is 3. And so we have -4/3. Now, 55, there's 0. There's no rise. So it's 0 over 2. Whenever we have a horizontal line, the slope is 0. Whenever we have a vertical line, the slope is undefined. So 56, we're going to go x1, y1, x2, y2. So we're going to go ahead and label these x1, y1, x2, y2, and then just plug it into that formula. So we have 3 minus 17 over -10 minus a minus 3. It's going to be negative, or 9 is 10 plus 3. So we get negative 14 over negative 7, which gives us a slope of 2. And that's it. Now, the slope of a line parallel to each line. Well, if we know the slope, we know that parallel lines have identical slopes, which means that if they're parallel, if we know the slope of one line, we know the slope of all the lines parallel to that. So they're equal. So here, the m equals 0. Why? Because y equals 5 is a horizontal line, and we just talked about horizontal lines having a slope of 0. So if we look then at the next step, perpendicular. Perpendicular lines have opposite reciprocal, which means if slope is rise over 1, we flip it and change the sign. So a over b becomes negative b over a. So here, where the slope is 3 over 2, we're going to flip it and change the sign. Negative 2/3. Yep, it's that easy. 61, we have a whole number, so instead of instead of saying the slope is negative 2, we'd write it as negative 2 over 1, and then go ahead, flip it, and change the sign. So, sketch the graph of each line. Here, we're going to add 1 to both sides. We get x equals 1. X equals 1 is a vertical line at 1. There you go. 63, what I like to do in these cases is put it into slope-intercept form, which means we solve for y. It's going to give us y equals 1/2 x plus 3. That means that we have our y-intercept at 3 and our slope is 1/2, and that's what the graph looks like. Okay, moving on. Now we're given different pieces of information. We have to put the equation into slope-intercept. 64, super easy. We're given the slope, we're given the intercept. If we know that y equals mx plus b, m equals the slope, b equals the y-intercept, then we just can go y equals slope times x, negative 1/5 x, plus 3, y-intercept of 3. And again, m is the slope, b is the y-intercept. Here, we write the slope-intercept form of each line. Now notice in each of these, y isn't solved for. And really, when we talk about solving for y, or solving for slope-intercept, what we mean is we solve for y. So we subtract 3x from both sides, and then we're going to multiply by negative 1. So we get y equals 3x minus 2. Remember, when we multiply negative 1, we want to distribute it throughout the entire side. 68, we're going to add 5 to both sides. Now, slope-intercept, a little weird here because we have x equals 5. However, whenever you have a straight line, whether that's horizontal, y equals 1, y equals 2, y equals negative 3.5, whatever, or a vertical line, x equals 1, x equals 5, that's how you write it. Okay, so moving on. Now these, we're given a point and the slope. So what we want to do is we first want to put it into, or how I would do it is I'd put it into slope, or point slope form, which is y minus y1 equals m times x minus x1. Once I do that, I can then solve for y, and that'll give me slope-intercept. So number 70, I'm going to go y plus 1 equals 1/3 times x minus 3. Distribute that negative 1/3, so I get y plus 1 equals negative 1/3 x plus 1, because negative 1/3 times negative 3 is plus 1. Then I'm going to add 1, or subtract 1 from both sides, and I get y equals negative 1/3 x. Now, on 72 and 73, an added level of difficulty. Okay, so what I'm going to do is I am going to first have to find the slope. Again, remember, slope, y2 minus y1 over x2 minus x1. It's going to be a slope of 3 over 9, or 1/3. Now I know it's a slope of 1/3 and it goes through those points. So I just pick a point. I'm going to pick that negative 4, 1, put it in a point slope, and again, solve for y. It gives me negative 3 equals 1/3 x plus 4/3. I'm going to add 3 to both sides. Adding 3 is the same thing as adding 9/3, so I end up with 1/3 x plus 13/3. Why is it? Because if I have 4/3 plus 3, same thing as 4/3 plus 3 over 1. Now I need a common denominator, so I'm going to multiply that 3 over 1 by 3 over 3. I multiply by 3 over 3 because 3 over 3 is multiplying it by 1, so I'm not actually changing its value. And that gives me 4 thirds plus 9 thirds, or 13 thirds. So that's my slope-intercept form. Now here, we're given a point it goes through and a line it's either parallel or perpendicular to. So here we know that it's parallel to a line y equals negative x plus 4. The slope there, whenever we don't have a number in front of a variable called the coefficient, we assume the coefficient is 1, or the coefficient is 1. Okay? So here we have a negative, so the coefficient is negative 1, which means our slope is negative 1. Which means all the parallel lines to this line have a slope of negative 1. So we're going to go y plus 3 equals negative 1 times x minus 4. We're going to distribute that negative 1, and we get y plus 3 equals negative x plus 4. We're going to subtract 3 from both sides. And we get y equals negative x plus 1. Here, perpendicular, so we know that our slope is now negative 5 halves. So we're going to go y plus 2 equals negative halves. Negative 5 halves times x minus 2. Distribute that negative 5 halves. And we get y plus 2 equals negative 5 halves x plus 5. Subtract 2 from both sides, and we get y equals negative 5 halves x plus 3. Okay, now from here on out, this is the stuff that most of the final is going to focus on. So, when we are graphing an equation of absolute values, remember, if it's a negative inside the absolute value bar, it actually kind of works the other way around. You'd think negative would move it left, positive would move it right, but it's the opposite way. So, that negative 2 moves it left 2 units, and then we have our standard absolute value v. Now, 79 is a little tricky. That plus 2 on the outside moves it up 2 units. That negative outside the absolute value, actually flips the graph upside down. So it's going to look something like this. Elimination and substitution, everybody's favorite. Okay, and the ones I gave you for some reason are really annoying because they all end up with fractions and decimals as their answer. So I apologize for that. Anyway, solving system by elimination. What we're going to do is we need to figure out how to make sure that we have a positive and negative in the same thing. So here we have 4x minus 20y equals 4. So I did this whole thing wrong. Hold on just a second. So what we're going to do is we're going to multiply that entire equation by a 2. Why a 2? Well, as you can see now, once we multiply that entire thing by 2, we now have a 20y and a negative 20y. When we add those together, they're going to cancel out. So that's what we're going to do. We have 8x plus a negative 4x, or 4x. 20y minus 20y is 0. And then we have 12 plus 4, or 16. Divide both sides by 4, and we get x equals 4. Now we need a point here, so what we're going to do is we're going to plug that 4 back in. Now it really doesn't matter which equation we plug it into, we're going to get the same answer. I'm going to plug it into the top one. 8 times 4 plus 20y equals 12. 32 plus 20y equals 12. Subtract 32 from both sides. So I'm going to get 20y equals negative 20. Divide both sides by 20. And I get y equals negative 1. So my point right there, my answer is going to be 4, negative 1. Now here, substitution, what we're going to do is we are going to isolate that y first, okay? So we're going to do that by adding 7x to both sides. So we get y equals 7x minus 1. We're then going to take that 7x minus 1 and we're going to plug it in for the y. That's the substitution part. So now we have negative 2x minus 7 times 7x minus 1 equals 7. Distribute. negative 2x minus 49x plus 7 equals 7. Subtract, or combine like terms, negative 51x plus 7 equals 7. Subtract 7 from both sides, and we have negative 51x equals 0. Divide both sides by negative 51, and we get x equals 0. We're then going to plug that 0 in, so we have negative 7, or negative 2 times 0, minus 7y equals 7. We're going to go negative 7y equals 7. Divide both sides by negative 7, and we get y equals negative 1, which means our answer is 0, negative 1. That's the point at which those two lines intersect, because that's the only point at which the same x and y make both equations true. So, sketch the system of inequalities. Inequalities is pretty easy. When we're sketching them, what we want to do is we basically just want to graph the line. Now here it says that y is greater than 2x plus 1, so we're going to shade in on top of the line. So anything within those purple markings is going to make that first one true. We then graph our second line, and that's y is less than or equal to. So we go underneath, and then we look for the point where they cross, and that's going to be down there, okay? So anywhere in that region, both statements will be true. You want to check your number, pick a number inside the region, it should make both statements true. Pick a number outside the region, it will either make neither one of them true or only one of them true. It definitely won't make both. Okay, so Monty's school, we're going to do 87. Word problems, everyone hates word problems. But if you think about it and just write them out as equations, they get easy, okay? So Monty's school is selling tickets to the annual dance competition. On the first day of ticket sales, sold 10 adult tickets and 3 child tickets. So what we need to do first is we need to sit there and define our variables. So we're going to say x equals the adult tickets and y equals the child tickets. So on day 1, 10 adult tickets and 3 child tickets, and we made $113. Day 2, 11 adult tickets, 9 child tickets, we made $187. So what we're going to do is we're going to treat this like a system of equations. So we're going to multiply that entire 1 by 3. That's going to give us 30x plus 9y. And as it says 3y, I'll change it. And it gives us 339. So then we're going to subtract the bottom one from the top one. Now keeping in mind that 3 is actually a 9. Like I said, don't worry, I'll get to it. See, I got to it. Okay, so we start off with 11x minus 30x. And that's going to give us negative 19x. 9y minus 9y is 0. And then we have 187 minus 339, and we get negative 152. Divide both sides by negative 19, and we get x equals 8. That means that an adult ticket is $8. We're then going to take that 8, go back, plug it into one of our equations, doesn't matter which one. I did the first day one, so 10 times 8 is 80, plus 3y equals 113. Subtract 80 from both sides, we get 3y equals 33. Divide, and we get y equals 11. So I know this is a little weird that child tickets are more expensive than adult tickets, but, you know, there you go. And you can always plug it into the other one to make sense. You can go 11 times 8 plus 9 times 11 equals 187. That would give you 88 plus 99 equals 187. And you know what? That's exactly what it equals. So we're good to go. Okay. Writing these containing only positive exponents. Now, in order to make sure that you know what you're doing, keep in mind that 1 over x equals x to the negative first. So when we write in positive exponents, what we're really saying is if you end up with a negative exponent here, write the entire answer as a fraction and put the negative exponents in the denominator. However, once you put them in the denominator, you get to treat them like you get to write them as positive exponents. For example, so we're going to do a couple of these. So 89, what we want to do is we're going to start off just by grouping everything together. So 2 times 4, then we're going to group all our x's together. Then we're going to group all our y's together. So when we are multiplying the same base, the base is that x or the y or whatever, and we have multiple different exponents, we add them all. -2 plus a -3 plus a -2 is -7. So we have 8 times x to the -7th times y to the -6th. Now notice we have two variables here with negative exponents. That means we're going to write this as a fraction and put them in the denominator. Now notice when we put them in the denominator, we write them as x to the 7th, y to the 6th. And that is a positive exponent. So that's what we mean. Let's look at 92. In 2 we have 4 times 3. And we're going to put our x's together. X to the 3rd times x to the -4th. And then y to the 2nd times y to the 0. One of the rules we went over is anything to the 0 power is 1. And that includes variables or numbers. So if I have 4 to the 0th power, or 4 to the 0, I just write that as a 1. 4 times 3, 12. X to the 3rd times x to the 4th gives me x to the -1. Y squared times 1 gives me y squared. So notice here we have a negative exponent, so we got to move that down to the denominator. That's going to give us 12y squared over x. Now, 93 through 96. What we're going to do is we're going to simplify the expression. Now, I'm going to do two, one with a addition problem, one with a subtraction problem. The addition problem, I basically just rewrite it without the exponents or the parentheses there. But I want to group things together. Okay, so first I want to write it out. And then I'm going to rewrite everything, grouping it together. So I have x cubed minus 6x cubed plus 3x squared minus 7x squared minus 4 minus 1. Combine like terms. Negative 5x cubed minus 4x squared minus 5, and that's my answer. Now, I'm going to do the next one. I'm going to do with a negative. Now, when I have that negative, what I'm doing is I'm distributing a -1 throughout. Or, if you want to view it this way, everything inside gets its sign changed. So I do 4a plus 3 minus 4a squared. Now, -6 minus a squared minus 2a. See, everything inside changed signs. Now, notice over on 96 I drew a little arrow. What I mean there is that, see how that's a negative inside? Even though I had a negative outside and a negative inside, it still changes its sign. So if I was doing that one, I'd end up with a positive 4k squared. So here, again, what I want to do is I want to write them all together. Negative 4a squared plus minus, or negative 4a to the 4th minus a squared plus 4a minus 2a plus 3 minus 6. Now that 4a to the 4th and that a squared, they don't have any other like terms. So I don't actually have to combine like terms, so I get that 4a and the 2a and the 3 and the -6. Finding each product. Foiling. Okay, remember, this is first, outer, inner, last. Now that first, outer, inner, last refers to where they are in the binomial. So those two 6n's, they're my first. The 6n and the -4, those are my outer, because they're on the outside of the binomials. The -8 and the 6n are my inners, and the -8 and the -4 are my last. So, first, 6n times 6n. Outer, 6n times -4. Inner, -8 times 6n. And finally, the last, -8 times -4. Do the math. We get 36n squared plus minus 24n, because we have that -4, minus 48n, because we have that -8, plus 32. Why plus? Because we get two negatives together. Now, 36n squared, we leave it alone. However, now we have a 24n and a negative 48n. We're going to add those together and get a negative 72n plus 32, and that's our answer. Next up, 99. We're going to go 7m times m plus 7n times 4 plus a negative 7 times m plus a negative 7 times 4. Same thing, so we're going to go 7m squared plus 28m minus 7m minus 28. So you have a 7m squared minus or plus 21m. It's an m. I missed a hump. Minus 28. There we go. Okay. Now, if we have a square, what that means is we're just multiplying it by itself. So that's how that would look. Now, what I really want to look at here is 106. Okay? Now, 106, we have what is called the difference of squares. Now we're multiplying again. These are called, so we're going to watch what happens when we write this out. We get 3p squared minus 21p plus 21p minus 49. Now those 21p's cancel out, so we end up with 9p squared minus 49. Why is it called the difference of squares? Well, we have 3p squared minus 7 squared, and we call a subtraction problem, the answer to a subtraction problem is the difference. So that is the difference of squares. Now here, we are factoring out the common factor. So we want to look for both a number and possible variables. Number 108, there are no variables. We have an n to the fourth in the first one, an n in the second one, and no n's in the third one. So we can't pull out any variables. We can pull out as a 5. Now what we want to do in order to get what's left over is we want to divide our coefficient or our variable by what we're pulling out. Okay? So if we have 40, we're pulling out a 5, we go 40 divided by 5, 8. So we get 8n to the fourth plus 50 divided by 5, 10n plus 45 divided by 5, or 9. And that's our answer. Okay, again, we've gone over this in class. We spent several weeks on this stuff. You guys should know it. This is not meant to replace all those weeks or to reteach you. This is to remind you what you should already know. This is to give your notes some sort of meaning if you didn't take good enough notes. Okay? So, moving on. When we factor each completely, we're doing the opposite of foiling. So in foiling, we took two binomials, multiplied them together, and we either got another binomial or more frequently a trinomial. Here, what we're going to do is we are looking at a trinomial or bigger, and we are reducing it to two binomials, or factoring it. So here, on these basic ones, we want to look at it and we go, okay, what, and we want to say, hey, what times what equals negative 3? That's our C. And when added together equals 2. So we're going to look at the factors of negative 3. Well, negative 3 is prime, so it's either going to be positive 3 and negative 1, or negative 1 and positive 3. I think I said that twice the same way. Anyway, negative 3 and positive 1, or positive 3 and negative 1. Now we go, which two of those add up to 2? Positive 2. Well, it's the 3 and the negative 1. So we're going to write this as b plus 3 times b minus 1. And that's our answer. Now, on 113, notice that we don't have a trinomial. We only have a binomial. So we look there, and when it says factor, we're going to do what we did earlier, just pull out the greatest common factor. Here, the greatest common factor is going to be 3a. So we end up with an a plus 6. Okay, moving on. Some of them, like 111, are a little trickier because we can't go what times what equals 32 and adds up to 24 because we got that 4 out front. So this is where you have that 7 steps somewhere in your notes. Step 1, multiply A and C together. 4 times 24, or 4 times 32, we get 128. Step 2, find the factors of 128, which have a sum of 24. That means they multiply the 128 and add up to 24. So we're going to start going through our factors. 1 and 128, 2 and 64. 3 doesn't work, so we're going to go 4 and 32, and 8 and 16. Haha, 8 plus 16 equals 24. So now, next step, we want to rewrite the equation, but instead of using our b, 24n, we're going to write that as a sum of 8n plus 16n, like so. 4n squared plus 8n plus 16n plus 32. We now want to group the first two together, 4n squared plus 8n plus 16n plus 32. And we can do that because of the associative property of addition. I'm going to factor out the greatest common factor from each little pair now. So from the first group, we can factor out a 4n. That's going to leave us with n plus 2. And in the second group, 16n plus 32. And this is kind of weird, but we can factor out a 32, or a 16. And we end up with n plus 2. Next step, factor out the common binomial, n plus 2. And then we write what we're left over with, which is 4n plus 16. And that's our answer. Now, depending, some places might want to see you pull this 4 out right here. So you're going to end up with 4 times n plus 2 times n plus 4. Now technically, if you're being asked to factor it out completely, that is the more correct term. But anyway. So here we have 4x squared minus 4x plus 1. And again, what we can do is we can actually go what times what equals 4 and adds up to negative 4. Let's give us a negative 2 and a negative 2. So we have 4x squared minus 2x plus 1. Now here when we have a negative in there, I'm actually going to write 4x squared minus 2x plus, and then I'm going to have negative 2x plus 1. And the reason for that is when I factor out, I can factor out a 2x from there, and so I get 2x minus 1. I'm actually going to factor out a negative 1. And that's going to give me that 2x minus 1 on the back. So now I'm going to factor out my 2x minus 1, and hey, check out what I'm left with. I'm actually left with 2x minus 1. So that's okay. I can also write this as 2x minus 1 squared if I'm feeling fancy. Moving on. So 118 through 121. Notice we have 4 of them. So what we're going to do is we're going to do the exact same thing that we were doing before. So because we have 4, what we're going to do is we're going to just break it into 2 sets of 2. Much like we did on step 1, 2, 3, 4. Okay? So we have 3k squared minus 18k squared. We're going to pull out the greatest common factor, which in this case is going to be 3k squared. Okay, and that's going to leave us with k, because 3k cubed minus 3k squared is k. And then we have negative 18k squared. We pulled out a 3, so that's going to give us a 6. So we have now that k minus 6. So now we're going to add to it the 2k minus 12. The hey Cleo, is the greatest common factor there is a 2. We'll pull out that 2, and lo and behold, we're left with k minus 6. Again, we then sit there and factor out that common binomial, k minus 6. And we are left with k minus 6 times 3k squared plus 2. Now, I'm going to do 121 to show you how we treat that negative. So we're not going to go minus 25a plus 15. What we're actually going to do is we're going to go plus a negative 25a plus 15. So we have that 15a cubed minus 9a squared. We can pull out between the 15 and the 9, the greatest common factor is a 3. And then between the a cubed and the a squared, we can pull out. How many a's can we pull out evenly from both? 2. So we have 3a squared, and then what's left over? Well, 15a cubed divided by 3a squared is 5a. 9a squared divided by 3a squared is 3. So we then go, now here we're going to pull out a negative 5. Why are we pulling out a negative 5 instead of just a 5? We could pull out a 5 and we'd have 5a, negative 5a plus 3. But when we look at the binomial we already have, we have 5a minus 3. So when we pull out a negative 5, what that gives us is negative 5 times 5a minus 3. So then we pull out the 5a minus 3, that's our common binomial. Multiply it by 3a squared minus 5, and that's our answer. Easy peasy, right? Yeah. So, sketch the graph of each function. A couple things we want to do here. Okay, so we're starting off with our c. Our c is the y-intercept. So because c here equals negative 5, then that means that our y-intercept is negative 5. We then want to find our axis of symmetry. Our axis of symmetry occurs along the line x equals negative b over 2a. Remember, this is the line that the parabola, how do we know it's a parabola? Because it's a square function. And that axis of symmetry is the line over which the parabola would be able to kind of fold onto itself. Negative b over 2a. Well, here, a is the coefficient of x squared, negative 2. B, coefficient of x, negative 4. And c is the constant, negative 5. So when I go b minus negative b over 2a, that's going to give me a negative 4 over 2 times negative 2. Or 4 over negative 4, negative 1. So my axis of symmetry is if x equals negative 1. Right there. So now we want to find our vertex. Now how we find our vertex is we take that negative 1 and we plug it back in, because that tells us the point at which our function crosses over that axis of symmetry. It tells us what our y value is when x equals negative 1. And that's going to give us a point, and that point, is going to be our vertex. So we have y equals negative 2 times negative 1 squared minus 4 times negative 1 minus 5. That's negative 2 times 1. Negative 4 times negative 1 is 4 minus 5. So that we have y equals negative 2 plus 4 minus 5, or y equals negative 3. So our vertex is then going to be at negative 1, negative 3. Right there. So we need one more point. Now what we're going to do is we're going to find basically the mirror image of our y-intercept. Here, our y-intercept was 0, negative 5. That point is 1 unit away from the axis of symmetry, which means its mirror is going to be 1 unit away on the other side. Then I connect the dots. And there we go. What you doing, Roms? Come here. Okay, next one, I'm going to do 123. Show you, so we have a equals negative 3, b equals negative 6, c equals negative 1. So our y-intercept is going to be negative 1. Plot that point, our axis of symmetry, negative b over 2a. So we have a negative 6 over 2a, 2 times negative 3. That gives us 6 over negative 6, or again, negative 1. So that's our axis of symmetry. We find our vertex by plugging that negative 1 back in for x. We end up with negative 3 times negative 1 squared minus 6 times negative 1 minus 1. This is negative 3 times 1 plus 6 minus 1, or 2. So that means that our vertex is going to be negative 1, 2. Plot that point, plot the mirror of the intercept, and there you go. Here, we'll go back and look at that for just a second. There you are. Now, let's look at 125. That's a little bit trickier. Notice we have no c. Well, that doesn't mean we have no c. It just means that c equals, well, a equals 1, b equals negative 2, and c would equal 0. That means that our intercept is going to be at the origin. Now, to find our axis of symmetry, we're still going to go negative b over 2a, or negative negative 2 over 2 times 1, or 2 over negative 2, or look, again, well, this time it's just positive 1. So that's our axis of symmetry. Vertex, we're going to plug the 1 back in. So we get 1 squared minus 2 times 1, 1 minus 2, or y equals negative 1. So here, the vertex is going to be at 1, negative 1. And then we want to mirror over the y-intercept. And there you go. Move on. Solve each equation by taking square roots. So what we're going to do here is we are going to basically isolate a and then figure out what the answer is. So number 26, we're going to subtract 10 from both sides. So we have 3n equals 18. Divide both sides by 3, and we have n squared equals 6. Well, we haven't solved it yet because that n still has a square component. So we're going to square root it. We're going to take its radical. And so we get n, because we know that roots and powers are inverse operations. So square root and squaring something are inverse operations. Just pick a number and do it with it, like a 7. Okay. So 7 squared is 49. The square root of 49 is 7. Anyway, a little off track. Anyway, so we have n equals plus or minus the square root of 6. Why do we do the plus or minus? Well, because, think about it. What's 6 squared? 36. And what's negative 6 squared? Also 36. So we put plus or minus 6 to say that it could be either one. But that's our answer. And notice that because we have an equation, because we have an equal sign, we're solving it. Same general idea with 128, except there you end up with a perfect square. Okay, solving each by factoring. Now this gets a little bit trickier because we're not going to have n equals 2 or something like that. But watch what happens here. If I add 12 to both sides, I get n squared minus 7n plus 12. So then we want to sit there and go, okay, what two numbers multiply to equal 12 and add up to equal negative 7? Negative 4 and negative 3. So notice when we now write it out, we're going to write x minus 4 times x minus 3 equals 0. So that means when either one of those binomials equals 0, that the entire thing is equal to 0. It's called the zero product theorem. So we're going to set this up as two separate problems. X minus 4 equals 0. We're going to add 4 to both sides, and we get x equals 4. So if x equals 4, then that whole thing is going to equal 0. Also true if x equals 3. And those are our answers. So we factor it out just like we have been. Then we're going to set each of the multiplication problem types to 0, and go from there. And if you guys need help, please let me know. So, next we're doing, quadratic formula. So, if ax squared plus bx plus c equals 0. So this is crucial, okay? If ax squared plus bx plus c equals 0, then the quadratic formula applies. X equals negative b plus or minus the square root of 2ac of square root of b squared minus 4ac over 2a. Okay? But notice it only works if ax squared plus bx plus c equals 0. So let's look at 134. Now 134, we should immediately note that nothing is on the same side. So I want to put everything over to the same side so we can get that look of this ax squared plus bx plus c equals 0. So we're going to subtract 135 and 2n from both sides. That means that I'm going to have 5n squared minus 2n minus 135 equals 0. So now that we have it in ax squared plus bx plus c equals 0, we can go ahead and just plug these numbers. A is 5, b is negative 2, c is negative 135. And we're just going to go ahead and plug it into the quadratic formula. So notice here we have negative negative 2 plus or minus the square root of negative 2 squared minus 4 times 5 times negative 135. Now, when we look at those two negatives, we see that they're part of the multiplication problem, which means that they're going to turn positive. So here's what I really want you guys to think about, though, is when you have 2 plus or minus 2704 over 2 times 5, which is 10, I want you guys to be on all of these, especially on the really big numbers, plug them into a calculator, see if it's a whole number, square root, and if so, write that down. So, where was I? Oh, so what I want you to do is I want you guys to make sure that when you have something like the square root of 2704, you actually put it into your calculator. And if it is a whole number, I want you to then sit there and use that whole number to get the answers. And not just leave it as the square root of 2704. And in this case, specifically, the square root of 2704 is 52. So we have 2 plus or minus 52 over 10. This means that we have 2 separate answers. Okay? So we have 2 plus 52 over 10 and 2 minus 52 over 10. That's going to give us 54 over 10 and negative 50 over 10. When we reduce that, so we're going to go 5.4 and negative 5. Again, if you, well, anyway. Moving on. I was going to say make sure that you're getting the right number of answers, but that's kind of answered in the next question set. So, in 138 and 139, we are asked to find the discriminant of each quadratic equation and then state the number and type of solutions. So that b squared minus 4ac, that's our determinant. Now, if our determinant is positive, we get 2 solutions. If our discriminant is, I said determinant, it's the discriminant. The discriminant equals 0. So if b squared minus 4ac is 0, then we have 1 solution. And if b squared minus 4ac is negative, we have no solutions, because you can't take a square root of a negative number. So here, I want to make sure that my B, my A, and my C are right. So on number 138, the first thing I want to do is add 9 to both sides. Now that's actually going to cancel both of the 9's out, so I'm just left with 4m squared plus 8m equals 0. So A equals 4, B equals 8, and C equals 0. Plug that into B squared minus 4AC. 64 minus 4 times 4 times 0. That's going to be 64 minus 0. And because that is a positive number, we get 2 solutions. If you have any questions, let me go. Have a wonderful evening.